Believe House, and we're about to do your homework or start on it for Lesson 3. You will have a test Thursday over this. Remember, from the lesson, we learned how to define the domain and range using inequalities. If the circle's open, you put a less than. If it's closed, you put less than or equals. The smallest number goes on the left, the largest goes on the right. The domain's left to right, the range is bottom to top. Oh, okay, so I'm not going to do all these for you. Let's just go through and do number 1. And before I start any more, let me record this or I will be talking for nothing. We are recording. A magical whiteboard appears in the office. So let's get going. Remember, we're going to put 2 dots on the x-axis, 2 dots on the y-axis. Let's just do the x first. So the first dot from left to right will be right here at the 0. The next dot will be, and let's just put this on a whole number right here, okay? So we're not going to make this a decimal. We're going to make it a whole number. That's kind of off, okay? So the domain goes from 0, and let's count over. 1, 2, 3, 4, 5, 6, 7, 8. Let's make this 8. Okay, then we're going to put 2 less than symbols. Okay. And now then, the 0 will get a less than or equal. The 8 stays less than, and the x is for your domain. Oh. Now then, let's do the range. So the range, let's use green dots. This starts right here, and I'm going to erase this dot, and I'm going to put my dot right here, and then right here on it. And let's just use whole numbers. This line's kind of off. So my range starts at 0 and goes up to 1, 2, 3, 4, 5. Okay, and then we're going to use less than symbols. And then the bottom one, the 0 has an open dot and the 5 has a closed dot, so we need to underline that. And then we're going to put y. Is this discrete or continuous? It is continuous because it's a line. Is it a function? Yes, because the x's do not repeat. A vertical line doesn't go through it twice. Now then, you're going to repeat the process. Let's do number 3 because that was not talked about, and it has an arrow tip. Okay? So number 3 has an arrow tip in it. This will be a little bit different. So let's do the x first. Okay, so on the x-axis, we're going to go start to the left and go to the right. So we're going to put a dot here. That's where the graph starts from left to right. Now then, this arrow means that the graph keeps going and going and going to the right. It will never ever stop going to the right. So if you have an arrow tip, you're going to draw an arrow tip on your x or y axis. Okay, and I will show you what that means in a minute. Now then, from left to right, we're going to start at, let's figure that out, -3, and it will never end going to the right. Most of y'all have heard of this before. If it never ends, if the value never stops, it approaches infin. That's right, infinity. So it's going to go to infinity, and you draw an infinity symbol with a lazy 8. Okay? So if there's an arrow tip in your graph, it's going to have an infinity symbol. Now then, let's put the less than symbols. The -3 has a closed dot, so we're going to put equal, and infinity will always have an equal bar. And then put the x. So the domain goes from -3 to infinity. That's how you would read that, and that's how you would write that down. Now let's do the range. The range goes from the bottom to the top. So the number on the bottom is going to be right here at the 1 in it. And then this graph will never stop going up, will it? So we're going to use another arrow tip. Notice that the arrow tip will turn into an infinity symbol, won't it? So the bottom number is 1. The top number is infinity. They're both going to have less than or equal symbols. And the range will have y on it. Oh. Now then, is it discrete or continuous? It is continuous. It's only discrete if it has just dots. And then, is this a function? Yes. Because the x values do not repeat. Okay. This one will also have infinity, and we'll do the range on this one. Okay, we're going to do the range on this one. Okay, so on the range on number 4, the bottom will never stop. So we're going to put an arrow right here, right? This graph will keep going to the bottom on it. Okay, and on the top, it's going to go to right here with an open dot, which means we'll just have a less than symbol. Now then, the range isn't, the infinity symbol isn't going up, it's going down. That's not positive infinity, it's negative infinity. So the range will go from negative infinity all the way up to, what is it, 1, 2, 3, 4? All the way up to 4. So if the arrow tip is over here or over here, that's negative infinity. If the arrow tip is at the top or to the right, it is positive infinity. So make sure you're using negative infinity and positive infinity when you need to do that, okay? Now then, let's put the inequalities in. So the negative infinity, remember, if you have infinity, it'll always have the equal bar, and the 4 will just have a less than symbol because it's an open dot, and you put y. And you should be able to do your x for this, okay? So this right here is important. Negative infinity is on the left or the bottom. That's the negative x or the negative y. Positive infinity is going up and to the right, which is your positive y or your positive x. And turn the page. You should be able to do these. This is just if they represent a function of x. Should be able to do this. What appears to be the domain, you should be able to do that. So this page you should be able to do on your own. The key on this is those infinity symbols, okay? We did not do that in the notes. Let me stop recording because this has been a blast. This is like at the end of all the Oreo cookies. Just You're about to watch another 17 seconds of Zen from Mr. Toops. I hope you enjoy this. It's a good way to end the lesson. Remember, you are amazing, you are created to do wonderful things, and you are awesome.